is, let's let that load up here. It excludes the base. So like whatever it's sitting on. So
Oh,
it's going to exclude this bottom part. Okay.
okay.
Now just to be clear here though, this one says the walls of this, meaning they're talking about the vertical walls. They're not talking about the ceiling. So
Oh,
the lateral area typically excludes the base. This one is also excluding the top.
okay.
Okay. Now here's maybe a better way to do this. Do you agree that there is a front face there that's 100 feet?
100. Yes, I do.
100 by 20, but there's two of them.
Okay. So,
And then there's the side one, which is 200 feet by 20, and there's two of those. There's the left and the right. You can think of this as the front and the back, and this is the left and the right.
okay, that makes sense.
Okay, so you multiply the two numbers together, 2,000, but then you times 2, that's 4,000. This one is 4,000, but then you multiply it by 2, that's 8,000.
Okay. Yeah. Okay, I got that. That's what. So I got a correction sheet, and that's the same answer. 12,000.
Yes, you got to combine them together. Right. Okay, where should we go from here?
From there, we you can solve 3 by doing 2. So here, let's see, 8, 9, and 10.
Give me one. Just give me one. 8.
9.
9. Okay. I'm just grabbing a snip here. Here we go. All right, a lawn sprinkler sprays a circular pattern 14 feet out from a sprinkler head. About how many square feet of lawn does the sprinkler water? So the idea here is there's a sprinkler head and it goes out 14 feet in all directions. That is a circle. Circle with a radius of 14. What is the area of a circle formula?
Pi times radius squared.
That's right. Now it's saying to use 22 over 7 for pi. And it says, and we know that the radius is 14 squared. Let me show you a shortcut here for doing this by hand. This is 22 over 7. 14 is really 7 times 2.
Okay.
Is that okay?
Yeah.
So now it becomes, on the top, it becomes 7 squared or 7 times 7 times 4. Do you see that the 7s now cancel?
Oh, yeah. What I was thinking was, couldn't you just make it 14 over 1?
Yes, you can do that, but it is you're multiplying it by itself. I mean, you still have to multiply. Are you allowed to use a calculator?
No.
No. So I'm trying to save you from. You should divide before you multiply. That saves you some heartburn when you do this. So now you just have to multiply 22 times 7 times 4, which is a little bit more doable than multiplying by 196 and then dividing by 7.
Okay. Times 7 equals 14 to the 1, 14, 15 times 4, 6 to the 1, 21, okay, 616.
And what are the units of that?
Feet squared.
Yes.
Okay. And then 10.
All right, number 10 here. Monica wants to tie a ribbon around the trunk of an oak tree that has a circular trunk about 20 inches in diameter. How do you think she knows the diameter of the tree?
Good question.
Yeah, that's maybe something you could throw at your teacher. So how do you know that? All right, not counting the ribbon needed to make a bow, about how many inches of ribbon are needed just to reach around the tree? So they're asking for this distance around the tree, which is a circle. Okay, so they're basically just asking you for the circumference of a circle from the diameter.
Okay. So 20 times pi.
Yes, but it says to round to the nearest inch, which means you have to take 20 and multiply by, I guess, 3.14.
Or would you multiply it by 3? Because I remember a while ago it said about.
This problem doesn't make a distinction, so I don't know how to answer that.
Okay.
I think 3.14 is better than 3, if you're asking me.
Okay. Hold on. 62.
0.8.
Oh, 0.8. Yeah.
So that rounds up to
63.
63 inches. Yeah.
Okay. What next? What did I circle? Here to have lost my paper out. And then okay. I struggled on 12.
12. Okay.
Oh, there it is.
All right. When I see a problem like 12 with fractions, I immediately want to eliminate the fractions. And to do that, you need the least common multiple. The least common multiple of 2, 3, and 4.
Okay, got it.
What is the least
common? It would be what do you call it? 12?
It is 12. So you can multiply everything by 12. Now this is one of those places that's going to save you time if you do it the way that I suggest, which is you divide before you multiply. Like, for example, 12, don't multiply it by 3, first divide it by 4, then multiply it by 3. Now you might say, well, I already know what 3 times 12 is. It saves you time when you're doing bigger numbers, basically. So divide before you multiply, save you time. So on the right, that's 9. 12 divided by 3 is 4, times 1 is 4. 12 divided by 2 is 6, times 1, so it's 6x plus 4 equals 9.
Okay.
I want you to solve this.
Okay. 6x plus. So is x 1? No. How do you get 6 to 5 is my question.
Okay, I guess it's been a while since you've done this. You're going to subtract 4 from both sides.
Oh, you need to isolate. Okay.
Yeah.
So that cancels out, and then it. Okay. How does 6x equals 5? I don't think I get it.
Okay, let's try another one here. All right, so have you seen this thing right here, order of operations?
Oh, wait.
This is for simplifying.
Okay.
We're not simplifying, we're solving. So when you solve, you go backwards, which means you undo addition and subtraction before multiplication and division.
Okay.
So if I give you 3x minus 2 equals 7, you're going to undo subtraction by 2 before multiplication by 3.
So would it be plus 2 on the 3x equals 7, or would it be plus 2 on the minus 2 plus?
So
yeah.
you write it underneath. You write it underneath because you're effectively undoing it.
Okay. So that's 4, and that's would it be a -2 or still positive?
Okay, let me start over here. So here's what you're looking at.
Because
You're looking at the side with the variable. And you should see, like, you should say, okay, there's multiplication by 3, and then there's subtraction by 2. You undo addition and subtraction first. If it's subtraction by 2, you undo it with addition by 2.
Yes.
Okay, so to answer your question, you always undo it with the opposite one here.
So that just cancels out to nothing, 0.
Yes, exactly. So it becomes 3x equals 9, and then you divide by 3.
Okay. So x equals 3 and then 1.
X equals 3.
Okay. Oh, okay. I get it.
Well, I'm going to give you a couple more here because this is you got to know this. This is not beyond you. You can absolutely do this. Let's say it's x divided by 4 minus 5 equals 1.
Okay. So plus 5, which is nothing, and then that's just x over 4 equals 1, and x would equal
No. You have to add 5 to both sides.
Oh, so that would equal 6.
Yes.
X over 4 equals 6, and so that's going to be 24 over 4 equals 6. X equals 24.
X equals 24. Okay. Let's try another one here. 3 plus 4x equals, are you okay with negative numbers?
Yes.
Okay. Sorry, that's not going to work. There we go.
Okay. Oh, okay. So would you add 3 then, because it doesn't add the variable?
What is the math operation? Like, what is
subtraction. Would you subtract 3 from both?
Yes,
that's
exactly.
Okay. So that's nothing, and then so that equals 12.
Yes.
Negative 9 minus 3 equals negative 12.
Yes, good.
So would x just equal -4? Negative 3?
Yes.
Okay.
Okay, couple more real quick. I know you got more to answer, but we really got to get this down perfectly. Let's say it's 5x minus 3 equals 8. Does not always work out nicely.
Okay. So plus, okay, so 5x equals 11. Let's see. 5x equals 11. Huh? So 2.1 or 2.5?
Yeah, so x equals 11 divided by 5, which is whatever it is, 2.2.
Okay.
Okay, I think you got it here. Do you want us to, where do you want us to go next?
After 10, let's see, what did I circle? I'm trying to find something. 17. Or did we just do 17?
No, we just did 12.
17.
Okay. Oh wow. Okay, so I see what they're doing here. This is all right. So we got scientific notation.
Yeah.
Let's just focus on the right. What is 10 to the 8th divided by 10 to the 4th?
10/4.
10 to the 4th. Now, sometimes when you can't divide it, you just leave it that way.
Oh.
Then you're done.
Oh, really?
Yeah, I know it's like, well, I thought there was more to do. Just a over 4 because we don't know.
Oh.
We don't know what a is. We don't know if a is 10 or 500.
Okay, that makes sense. And then last one, I skipped over it on accident. 14
Okay,
and 13, if possible.
Let's go back and do it. You said which one do you want to do first?
Let's do 14 first.
Okay.
Oh, never mind. I got 13, so just 14.
All right. Well, I'll check your answer. Let's do this one. This one's the distributive property. Sometimes confused with multiplication because you are multiplying 3 times x and 3 times 2. So that's 3x plus 6. And then you similarly do it on the right here. 2 times x, 2 times 3.
So
Now you combine like terms.
So what would the like terms be? X 2?
Anything with an x in it. Yeah.
Okay,
Like,
so x to the second power or x squared.
You're adding 3x plus 2x. It's like me
Oh,
saying you've
5x.
got 3 eggs and yes.
Or 5x to the second 5x squared.
It is not 5. It is not 5x squared. You're not multiplying. You're adding
okay.
them.
No. Okay.
And then it's 6 and 6. So that's plus 12.
Okay. So that just 17x.
Nope, you can't. It's like 5 eggs and 12 pieces of bacon. You cannot combine.
Oh, okay. So that's it.
Yes. Let me give you another one here to try. Okay, I want you to simplify this one for me, please.
Okay. Okay, so that's going to be 4x and no, that's going to be 3x plus 20x, right?
3x plus 3 plus 4x plus 20. What is your final answer?
Oh, 3x plus, okay. How do you get plus 3?
You multiply the 3 times both. That's the distributive property.
Oh, okay. That makes sense. So 3x plus 3, that's 6x plus 24x.
7x. You're combining the 3x and the 4x.
Oh, okay.
So they both have an x.
Oh, okay. So I see the order that you do this. So 7x plus 23. That's it.
Yes. So let's try one more here. See if you got it.
I think I got
4 times 2 plus x plus 5 times 1 plus x.
Okay. So 4x plus 6. No. 4x plus 6 or 4x plus 8?
So is it 8? You've got 8 plus 4x plus 5 plus 5x.
Okay. Yeah. Okay, I got that. So 4x plus 5x, that's 9x. So 13 plus 9x.
Yes.
And then you said you wanted to check my answer for 13?
Yes. So let me snip that in here. Let me give you the answer. Actually, you give me the answer. What do you have here?
I got 5y squared.
Okay. So you're going to combine the 3x and the minus x. And I usually do this in color, so I might as well do that here for you. And then it's 2y plus 1y. So 3x minus 1x is 2x. 2y plus y is 3y. So you can only combine the ones that are like terms, meaning like if they have an x, you can combine them. If they have a y, you can combine them. You have to
Okay,
differentiate
so
between them.
is that the end?
That's
it?
the end. Yeah, you
Okay.
cannot combine them. So let me give you one to try here. 6x minus 2 minus 3y minus 4x plus 5y.
Okay, so 6x minus 4x, that's going to be 2x. And then 3y plus 5y, that's going to be 8y. So 2x plus 8y.
So I agree with the first part. 6x minus 4x is 2x. The operator, though, goes with it. So it's minus 3y
Oh, okay.
plus
So that's going to
5y.
be 2y.
Plus 2y. Very good. Let's see if we can get this all the way down here. Let's see if we'll give you just a little harder one here. Let's say it's 2 times x plus 3y plus 4 times x minus 2y. So you're going to first distribute in.
So 2x plus 3y or
6y.
6y plus 4x minus 2y.
You're multiplying both.
Okay, minus 8y. Yes. Okay.
Okay, so now you combine like terms.
Okay, so that's going to be 6x.
Okay.
Plus negative 2y, or yeah.
You can say it either way. You can say plus negative 2y, or you can write 6x minus 2y. They're the same.
Okay.
All right. Any other really quick questions you can answer on this review?
No.
Okay. So if we have some time, if we do end up doing some lessons next week, I definitely want to do some more problems like the ones we did here at the end. Notice some issues there, some small things that we can clean up with just a quick lesson on that. Same thing with solving the equations. What's interesting is like these, you should know these really well. For some reason, they just got missed. So if you do some lessons next week, that's what I would recommend.